In this first video, I'm going to go through some of the basic operations, basic calculations that you'll see on the TI-8X series. And again, whether you are using an 83, an 84, 84 plus, the CE, I just happen to be using the color edition on the monitor here. But the differences between the 83 and 84 and all those different models are not really going to be important for this group of lessons. They come down more to memory, certain apps that we're not going to be using. So any TI-8X, 83 or 84 will have the same features as the same keystrokes that I'm showing here. Okay, so entering calculations. Let's start with that. From this standpoint, it functions mostly like any other scientific calculator in that you use the operations on the left side and you get the result over there on the right. Okay. Now, a couple of things when we talk about adding and subtracting. The first thing is negative numbers. So the first thing I want to point out is the difference between this key and then this key. This is minus, this is negative. So if I take something like, if I put, let's say I want to find -8 squared. Now this is going to produce an error. And the reason it's giving the error, just kind of quit, is that I didn't use -8, I used the subtraction -8. Under most circumstances, we kind of treat them the same. The TI-84 is more particular on this, so make sure if you're entering a negative number, you use this negative key and not the minus key. So this one will work a lot better. So you can use exponents as we've already seen. 6 squared, just to be the square key over here. You can use a different exponent by this caret. So let's try -4 the whole thing to the third power. So -4. And again, I have to use parentheses. I'll show you why in a moment. -4 to the third power. It does make a difference when you use parentheses, and I'll get into that when we get into multiple operations. Let's change this to talk about squares for a moment. I want to talk about the parentheses. So if we have, let's say, -5 squared, I'm going to get -25. But -5, the whole thing squared, you know, -5 times -5 should give you a positive. Again, it's parentheses. I have to make sure I have to use parentheses around that -5, and now it gives the answer that we were looking for. So any other exponent, so you can use squared here, you can use any other exponent here. If I take -1, remember that's 1 over, so that'll be, in this case, 1 over 625. I do want to point out also this ANS. So what ANS does, this is a very useful feature, and it's down here above the negative symbol, and what it does is it stores the very last calculation that you've done. So this 0.0016 is already stored as this variable ANS. It's not A times N times S, it's ANS, it's one variable. So if I want to take this and multiply by 1,000, I can take second. Yeah, you got to use second because the ANS is in blue. It's above the key. So I'm going to press second, then the ANS key, and then I can say multiply by 1,000. As you probably noticed already, you don't need to explicitly, in most cases, you don't need to explicitly push ANS. If I wanted to say take that 1.6 and subtract from 10, then I could type in something like this, 10 minus ANS, and 10 minus 1.6, and get to 8.4. So where could this be useful? Well, let's talk about the square roots. So when you take a square root, so second x squared, the second x squared is a square root. So that's how we find the square root of a number. Your model may not actually give you the square root symbol. It may give you a square root with a 49 next to it, but it's doing the same thing. Now, if we take the square root of something that's not a perfect square, so the square root of, let's say, 10. Now, the square root of 10 is what we call an irrational number. In other words, it cannot be expressed as a fraction. And if you try to express it as decimals, you're going to get an infinite set. You're going to get infinitely many decimal places, and there's not going to be any repeating pattern, as opposed to a rational number. 1/3 is a rational number because, yes, it's infinite decimal places, but it has a pattern. They're all threes. For square root of 10, let's do that one again. For square root of 10, there is no pattern, and it doesn't end. We're seeing 8 decimal places here, but that's only the first 8 decimal places of the approximation. So the only way to express square root of 10 exactly is by writing square root of 10. This, what you see here, is an approximation, and it's the first 8 decimal places that are being shown. Now, if we have to square this and get back to 10, so let's say, let's start with 3.16. I'm going to round this to 4 decimal places. 16227. So 1623. And then we square it. Now, it's not going to be exactly 10. We've overestimated a little bit. That's why we get something a little bit more than 10. So the only way I'm going to get this number, this exact number, into the calculator is by using ANS. So once more, let's start with the square root of 10. And now I can do ANS. In fact, I don't even need to type ANS. I can just, if I just hit the square key right away. So when I do that, then I'll get back to exactly 10 because it's taking this whole thing. All the number of, remember, like I said, this is 8 decimal places, and in most applications that'll be enough. But even if I take all 8 of them, well, this might still give me 10 just for rounding, but oh, see, there you go. This is when I put the number it gave me, 9.9. So the only way I'm going to get this, there are more decimal places here that we're not seeing. So you're going to have to use ANS. You're going to have to take the original number and square to get back to where we started. Okay, so that's square roots. The other thing is higher level roots. Actually, we'll get to that in a moment. I want to talk about multiple operations and parentheses. You can see I have an example over here. So if you're taking an algebra class, you've seen order of operations. You got to be careful about how we enter this. If we take a look at the way this is written out here, 8 plus 6 divided by 3. 8 plus 6 divided by 3, well, that's going to be 8 plus 2, because we're going to take the division here and do it first. 6 minus 1, you've got to do the numerator and denominator separately. 8 plus 2 over 5, which is 10 over 5, which should give us 2. Again, if I just type this in as is, 8 plus 6 divided by 3 divided by, yeah, see, this is not going to, I don't even know what this is going to come out to. It's not going to be good. Okay, so again, we have to use parentheses around our numerator and denominator separately. So what I'm going to have to do is I'm going to start with the parentheses just for the numerator. And I'm going to put 8 plus the 6 divided by 3. It should handle. So the calculator will do order of operations. So it will actually do 6 divided by 3 first. So we don't need to put parentheses around the 6 divided by 3. Sometimes you might need to put nested parentheses. And then I'll put 6 minus 1 over here. Now this should give us 2.